In this video, we're going to have a look at equations with fractions, including variables in the denominator. When working with equations with fractions, your first aim will be to get a common denominator. Once the denominators are the same, you can make the conclusion that the numerators also have to be the same, and then only work with the numerators from there onwards. Then you will have either a linear or a quadratic equation that you need to solve. If you want a more in-depth look at how to determine the common denominator and simplify fractions, you can have a look at algebraic expressions video 12 and 13, of which the link is in the description below. In example 1, we now have three different denominators and we need to determine the common denominator. In this case, that common denominator will be 4x. Next, we need to form an equivalent fraction for each of the three fractions with the new denominator of 4x. The first fraction still needs to be multiplied by 4, which is repeated at the top to get 24. On the right, the first fraction still needs to be multiplied by 2, and that will give us 6 when repeated at the top. And the last fraction needs to be multiplied by x, and repeated at the top, we will get minus 1x. Now, because the denominators are the same, we can continue working only with the numerators and say that 24 has to be the same as 6 minus x. Here we now have a linear equation, so when I solve x, I will have 6 minus 24 and x will be minus 18. When you have fractions in your equations, it is important to always take into account the restrictions there may be. That will be the x values that will cause the denominators to become 0 and then of course be undefined. In our first example, there are three denominators to take into account, and in this case, x cannot be equal to 0, because if x is 0, we will have denominators that are equal to 0. In our case, the answer was x is minus 18, which is perfectly acceptable as an answer. In example 2, we once again have fractions in our equation, and we want to get a common denominator. But all of these denominators have more than one term, so we first need to factorize. The first denominator can't be factorized, and I simply put it in a bracket. The second denominator has a common factor of 2, and there will be a bracket of x minus 4. And the denominator on the right-hand side is a trinomial which can be factorized. Now we can determine the common denominator, and that will be 2 times x minus 6 times x minus 4. Now we need to get an equivalent fraction for each of the original fractions with this new denominator. So the first fraction still needs to be multiplied by 2 and x minus 4. So the 3 at the top will also be multiplied by 2 and by x minus 4. The second fraction's denominator should still be multiplied by x minus 6, and that means the minus 5 will also be multiplied by x minus 6. Lastly, the fraction on the right should still be multiplied by 2 in the denominator, so x minus 24 will also be multiplied by 2. Again, because our denominators are now the same, we can accept that the numerators should also be the same, and I'm also going to simplify them now. So the 3 will be multiplied by 2 to get 6, and then multiplied in to get 6x minus 24. Then I'll multiply in the minus 5 to get minus 5x plus 30, and on the right hand side multiply in the 2 to get 2x minus 48. When I simplify the left hand side, I will get 1x plus 6, and now I can solve this linear equation. So when I move all the x's to the right, I will immediately have 1x, and the constant will be 6 plus 48, so x will be 54. Also now remember to take into account your restrictions. and those are the x values that will cause our common denominator to become 0. This will in reality form another equation where the denominator cannot be equal to 0. That means this will be when x is equal to 6, and that's not allowed, or x equal to 4 is not allowed. So our answer of 54 is acceptable. In example 3, again, we have fractions, but this time none of the denominators can be factorized any further. It is, however, important to recognize that the last denominator of 2 minus x is very similar to the first denominator of x minus 2. We can then manipulate this in algebra to change the x to positive and the 2 to a negative by taking out a minus. When you now rewrite that last denominator as x minus 2, taking out a minus, it is useful to immediately write that negative value in front of the whole fraction, and then this will become a positive value. Our common denominator can now be determined, and that will be x minus 2 times x minus 3. Now we get our equivalent fractions, and the first fraction still needs to be multiplied by x minus 3. The second fraction of 1 in the numerator has to be multiplied by x minus 2, and 2 has to be multiplied by x minus 3. Now that our denominators are exactly the same, we can continue working only with our numerators and simplifying them. The left will be x squared minus 3x. On the right we'll have x minus 2 plus 2x minus 6. Now we have a quadratic equation, and this means we will get everything on one side equal to 0, starting with our x squared. Next we have minus 3x on the left, and on the right we have 3x, which will also be subtracted on the left to get minus 6x. The constant value on the right is minus 8, and this will be added on the left hand side. Now we have the standard form, which means we can factorize and then get the two separate answers. Lastly, we once again need to focus on our restrictions, and those are the values that will make our denominator 0. So that is the equation x minus 2 times x minus 3 cannot be equal to 0. This means that x cannot be equal to 2 or equal to 3. This means that we'll have to indicate that x equal to 2 is not valid for our question, and the only acceptable answer is x is equal to 4.